Hi friends, in this video we are going to discuss about the concept of transformer and also what is the working principle of a transformer. Now coming to here, actually what is transformer? Simply here, the transformer is a static device. Actually what is the meaning of static? Static means stationary. It means transformer does not consisting of any rotating parts. That is the reason why transformer is a static device and which is used in the power systems or power transmission systems to transfer the energy from one circuit to another circuit without change in frequency. This term is very important. Okay, so transformer is a static device which is used in the power systems or power transmission systems to transfer the energy from one circuit to another circuit without change in frequency. But what is the principle we are using to transfer this energy from one circuit to another circuit? Means with the help of the principle of Faraday's law of electromagnetic induction or mutual induction principle. So with the help of this principle, we can easily transfer the energy from one circuit to the another circuit in case of transformer. And here the most important point is it is commonly used. That means what? This transformer commonly used to step up the voltage or to step down the voltage levels, but there is no change in the frequency. Okay, there is no change in the frequency. Now this transformer is mainly used to transfer the energy from one circuit to another circuit. It means what? If you want to step up the voltage or if you want to step down the voltage, we can directly use this transformer. But while we are changing from low to high and high to low voltages, but we need to fix this particular frequency. That is the reason why there is no changes in the frequency. Now coming to the working principle of a transformer. Okay, the working principle of a transformer. So before we are going to discuss about the working principle of a transformer, first you can observe this diagram. So here this is the transformer core. And here this complete core is laminated. Why we are laminating this core means in order to reduce the losses. Okay, so actually when we are going to discuss about the complete information of losses in a transformer, we'll discuss every point, how we are getting the losses and how to reduce the losses. So everything we'll discuss while we discussing about the losses concept of a transformer. Now this is the actually this part is the transformer core. And on this transformer core, we are placing the primary winding like this, and here the secondary winding like this. Now, for this primary winding, always we need to connect the supply voltage like this. Okay, for example, Vs indicate the sinusoidal voltage, or we can also call it as alternating voltage. It means for primary winding of a transformer, we must connect the supply only. But coming to the secondary winding, always we need to connect the load. Okay, always we need to connect the load. So if we are going to connecting the load, then this secondary winding completely closed. Okay, now it means for primary winding of a transformer, we are connecting alternating voltage supply, and for secondary winding we are connecting the load. Now what is the working principle of a transformer? Now we need to discuss about the actual working principle. Now see here, whenever we are going to apply the alternating voltage across the primary winding, then there is a flow of alternating current. For example, in the primary winding, the current flowing is I1, and for example, I am giving the name for the current which is flowing in the secondary side, that is I2, and here the number of turns of a primary winding are N1 and number of turns of a secondary winding are N2. Okay, now coming to the working principle, whenever we are applying sinusoidal voltage or alternating voltage across the primary winding of a transformer, then alternating current I1 will flow through this primary winding. Whenever this alternating current flowing through the primary winding, there is a production of MMF. Here MMF means magnetomotive force. Here this MMF is always the product of number of turns of a primary winding with the value of current which is flowing in the primary winding. It means N1 represents the number of turns in the primary, I1 represents the alternating current which is flowing through the winding, primary winding. Okay, so when the alternating current is flowing through the winding, there is a mmf, that is magnetomotive force, and if you are getting this magnetomotive force, then there is a production of flux, that is represented with the phi, and this phi is always alternating flux only, because we are applying alternating voltage. Because of this alternating current I1 will flows, and because of this alternating current there is a production of alternating flux, that is phi. Okay, so this phi is alternating flux, or we can also called as change in flux. Okay, or we can also called as change in flux. Both are same. Alternating flux or change in flux, both are same. Now this alternating flux or change in flux is produced in the primary. Okay, now because of this alternating flux or change in flux in the primary, then there is a production of electromotive force, that is 1. It means we are getting the electromotive force in the primary side. That's why I'm giving the name for EMF 1. So EMF means electromotive force is produced in the primary side due to the change in flux which is produced in the primary. Now the most important point is this change in flux is flowing through this transformer core like this, and this change in flux again linked with the secondary windings. Okay, the secondary windings. Now when this change in flux is linked with the secondary windings, again there is a production of electromotive force 2. That is electromotive force 2 means the electromotive force produced in the secondary winding. That's why I'm giving the name for EMF is EMF 2. Okay, so due to this change in flux and this change in flux linked with the secondary winding, there is a production of electromotive force 2. Now when there is a production of electromotive force in the secondary side, then there is a flow of alternating current I2 through this particular winding, and if we are connecting this load across the secondary winding, then the current I2 will flow through this load. It means what? We are applying alternating voltage across the primary winding, and this, because of this particular concept or mutual induction process, there is a flow of current or flow of energy in the secondary side. That is the reason why transformer is working on the principle of Faraday's law of electromagnetic induction. Okay, so this is the working principle of a transformer. Okay, now coming to the most important points about this working principle. Now see here. So working principle of a transformer, the most important points are, first thing is the basic principle behind the working of a transformer is the mutual induction between the two windings linked by the common magnetic flux. Okay, next point number 2 is basically a transformer consisting of two inductive coils like primary and secondary windings, and the coils are electrically separated but magnetically coupled to each other. Okay, so whatever the primary and secondary windings are taken, so these two are electrically separated but magnetically coupled with the help of what? This particular magnetic field. Now third point is, when primary winding is connected to a source of alternating voltage, then alternating magnetic flux is produced in the winding, and the core provides the magnetic path for the flux to get linked with the secondary winding. Okay, now most of the flux gets linked with the secondary winding, which is called the useful flux. We can also call it as main flux, and the flux which does not link with the secondary winding is called the leakage flux. And because of this leakage flux, we are going to get some losses, and because of this leakage flux, the system performance is also somewhat less. And we'll discuss about all this mutual flux or useful flux or leakage flux later, because when we are going to get the or checking the performance of a transformer, all these terms are very, very important. Okay, now coming to the another point, that is, as a flux produced is alternating, then EMF gets induced in the secondary winding according to the Faraday's law of electromagnetic induction principle. And here this EMF is called as mutually induced EMF, and the frequency of the mutual induced EMF is same as the supplied frequency. So what is the meaning of this? So coming to the first point, that is, now see, so the principle we are using is what? Mutual induction process or Faraday's law of electron induction process. Now point number 2 is what? So basically transformer consisting of two windings, those are primary winding and secondary winding, and across the primary winding we are applying the alternating supply, and because of this alternating supply, alternating current is flowing. When the alternating current is flowing in the primary winding, there is a production of what? So magnetic flux, that is alternating magnetic flux. There is a production of alternating magnetic flux, and here because of the magnetic path, it means what? Core, because of this core there is a path for the magnetic flux, that is change in flux, and this magnetic flux or change in flux linked with the secondary winding. So when this magnetic flux is linked with the secondary winding, then there is a production of electromotive force 2 in the secondary winding, and most of the flux linked with the secondary winding, so that is useful flux. And the flux which is not linking with the secondary or primary winding, then that is called as leakage flux, and due to this leakage flux we are going to get some less performance in the transformer. And here because of this alternating flux only we are going to get the electromotive force in the primary and secondary due to the Faraday's law of electromagnetic induction. And here the EMF we are getting because of the mutual induction process. That is the reason why we are calling as mutually induced EMF. And here whatever the frequency of the supplied voltage, same frequency for this produced EMF also. Okay, so like this the working principle of a transformer will place, and the working principle of a transformer mainly depending upon the Faraday's law of electromagnetic induction. And the last point is, if the secondary winding is closed circuit, then mutually induced current will flows through it. It means what? Because of the change in flux which is linking with the secondary winding, then there is a production of EMF in the secondary side, and due to that there is a current flowing in the secondary, and that current is directly flowing through the load which is connected across the secondary winding, and hence the electrical energy is transferred from one circuit to the another circuit due to the Faraday's laws of electromagnetic induction principle. Okay, so this is the concept of working principle of a transformer. So thank you so much for watching, and please do subscribe my channel for more updates. Thank you.